Okay, class, we're going to get in a little bit more in depth with the tools that geographers use, and we're going to start with latitude and longitude. So, as you may be aware, latitude and longitude are measured using imaginary grids of parallel lines and vertical lines to locate points on the globe. One such example would be the equator. It's that big center one that everybody is always pretty much able to find pretty easily. It's halfway between the north and south poles, measured horizontally going across the Earth, and it separates Earth into two equal halves called the northern and southern hemisphere. You should be familiar with some of this. This is just a review. Lines of latitude are lines running parallel to the equator, meaning running the same direction. A good way to remember this is latitude, flatitude, all right? Latitude lines are flat going across. They actually, even though they're going across, they're measuring the distance between north and south of the equator, okay? So it's measuring whether something is farther north or farther south. Latitude is measured from 0 degrees at the equator to 90 degrees at the pole. Think of a 90-degree angle, okay? If the North Pole is here, then this could be where my line of latitude is. Not a very straight line, but you get the idea. Locations north of the equator are referred to by degrees north latitude, okay? So if this, for example, is 30 degrees. Once again, I'm going to try to do this on the PowerPoint. Okay, I have to put north here, okay? Because if I don't put north here, then if I just say 30 degrees latitude, people aren't going to know whether or not it's in the north hemisphere or on the south, because there's going to be another 30 degrees south here, okay? And so I'm trying to be specific here by saying north or south. So when it's south, I have to put the S for south. Each degree of latitude is roughly equivalent to about 111 kilometers. That equals about 70 miles, to put it in more American measurements. In between these degrees, in between these miles, is an even smaller unit of measurement. So if we're thinking, kilometers, meters, centimeters, millimeters, there's an even smaller unit that is under degrees, and these are called minutes. And a minute is about equal to 1.2 miles. A minute of latitude can be even further divided into what is known as seconds. And you can see these little designations here. You have the apostrophes or the double apostrophes. And a second is equal to about 0.02 miles. So it's not very far at all. But using these, we can pinpoint exactly where things are. Longitude is divided the exact same way, so it's not broken up any differently. You're going to use the same instances of degrees, minutes, and seconds when you're measuring longitude as well. With that said, longitude are the lines on a map that are going up and down from pole to pole, but they're actually measuring east and west. The lines of longitude are also known as meridians. The prime meridian is 0 degrees, and the reason why the prime meridian is where it is, okay, it's easy to say, if we're looking at an up and down perspective, why the equator is where it is, because it's in the middle, okay? But how do you decide where the prime meridian is if the Earth is completely round when you're looking at it up and down? Well, the reason why the prime meridian is where it is because these systems were developed during the time where Great Britain was the major world power. And so the prime meridian runs through Greenwich, England. Okay, and we base not only our lines of longitude off of this, but we also base our time zones off of this. Because the globe is completely round and we're not measuring from pole to pole, we're just measuring around. The points going west to go from 0 to 180, and the same thing for the points going east. When you add these up together, obviously they create 360 degrees, which is a full circle. Okay, so whereas the lines of latitude are parallel to each other, the lines of longitude are not. If you look at the prime meridian here, you notice that it goes directly straight up and down, right? From how we're looking at it, right? Because we have the globe flattened out against our computer screen or again on our tables or in a book when we're looking at a flat paper map or a reference on from this perspective, right? Okay, well, if you look at the other lines of longitude next to it, you notice that they curve out a little bit. That's because they have to meet at the poles. Okay, where the equator and the lines of latitude, they don't actually meet at poles. They just continue to go around. So while the length of the lines of latitude are not as long as you go farther north or farther south because it kind of tapers off to the north or south pole, the lines of longitude are going to vary in length as well, but they're also not going to be parallel because they can't be. Okay, if I were to draw parallel lines to the prime meridian, it would go through the globe like this. And this isn't a straight line, forgive me, I'm not an artist here. Okay, well, as you can see, the lines of longitude don't do that. They have to curve out to meet at the poles here and here at the same place, but they have to kind of curve out in order to do that. Okay, and we use the same units of measurement as we do for latitude, right? Degrees, minutes, and seconds. However, whereas we talked about the degrees and the distance between the lines of latitude being equal and the distances covered by them more equal, the distances of longitude are going to vary more with location because of this curvature, because they cannot be perfectly parallel like lines of latitude. 1 degree of longitude varies about 101 kilometers at the equator, but to essentially the distance covered by a point at the poles. So how do we locate places with coordinates? We use these obviously to find absolute location of a place, not the other location, which is relative. So here's an example of an absolute location. We're going to look at New Orleans. Okay, see where this arrow is pointing right here. Okay. Using the measurements here on the globe, we can see that New Orleans is 29 degrees 57 minutes north, 90 degrees 4 minutes west. Okay, so latitude comes first, then longitude. Okay, I hope you guys got a good understanding of latitude, longitude. Hopefully that was just a review for you. Let's look at some other tools that geographers use. Now that we have satellites and all of this high-tech computerization of everything, we no longer need to rely just on maps that people drew by hand. We can now use tools such as GPS, remote sensing. And these are going to be much more accurate because they don't involve as much human error. Remote sensing is the process of collecting data about the Earth from far above the Earth's surface using satellites. There are different types of satellites. One example here is the Landsat satellite, which uses wavelengths of light, including infrared, to produce an image. It uses the Earth's surface, the warmth that the Earth both absorbs from the sun and that also is being projected out from the Earth's core. And so it shows up as different colors depending on how warm or cold an area is. So this is kind of an example of what's going on in space when we're using remote sensing. And this is a Landsat image of Virginia. As we go farther in, closer to a specific area, such as Virginia Beach, you can see that we start seeing a more vast array of colors. Another satellite is called the Topex, or also known as the Poseidon satellite, and this measures features on the ocean floor. And it's used very much like sonar, as you can see here. It emits a high-frequency signal that goes all the way down to the surface of the ocean and is reflected off and back to the satellite. And this is kind of what you will see when they're measuring and getting information from this type of remote sensing using satellites. Global Positioning System, also known as GPS. You should be very familiar with this. I think everybody uses it now. It is a radio navigation system of at least 24 satellites that allows its users to determine their exact position on Earth. Each satellite orbits Earth and transmits high-frequency microwaves that contain information about the satellite's position and the time of transmission. So this time is pretty important when we're trying to get somewhere using the GPSs on our phones. A GPS receiver calculates the user's precise latitude and longitude by processing the signals emitted by multiple satellites. We also have the C-beam. And this technology is really similar to the Poseidon or Topex satellite in that it's used to map the ocean floor. Whereas the original Poseidon satellite uses something that's like sonar in that it sends high-frequency waves down to the ocean surface, C-beams actually use sonar, okay, which is using sound waves. And that is really the definition of sonar. Sonar is all about sound. Okay, but it does work in the same way in the sense that instead of a high-frequency radio wave, it's a sound wave that's being sent out and bouncing off of the objects and coming back to give us a relative idea of what the objects underwater look like. And this is an example of how it is used. So take a minute and just kind of look at that. Time zones. So you may be somewhat familiar with time zones. So the opposite of the prime meridian is known as the international date line, and this serves as where we actually cross over into another day when we are actually traveling across the globe. Time zones were originally developed by railroads to more accurately reflect when trains would be arriving when they were going extremely long distances. Because during this time, the British Empire was kind of at the peak of its power, we base our time zones off of the same place where the prime meridian is. And so kind of look over this information. I'm not going to just read it to you, but it's there for your benefit. So because Earth takes about 24 hours to rotate, it is divided into 24 time zones, each representing a different hour. And you notice that the 0 time zone is located at that prime meridian. Okay, it's where we started, like right at, say, if we were at noon, we either add or subtract hours from it depending on how far away we are and whether we are going east or west of it. Most of the civilized world does have, and I use civilized very loosely, but does use these time zone systems. You notice, though, that places like Saudi Arabia do not. And here, 180 degrees across is the international date line. And you'll also notice that some of these lines and some of these zones are not perfectly parallel to each other. Some of them have little outliers here that jut out. Each time zone is roughly 15 degrees wide. Using your measurements from latitude and longitude, you should be able to figure out about how many miles that is. But they try to correspond roughly to the lines of longitude. In local areas, however, time zone boundaries do get adjusted, and there even are some areas like certain states or cities who either will adjust them to the local areas for convenience if there is a specific line of a longitude or a time zone that's going through, say, the middle of the city, and that way there's not like an hour difference between one half of the city and the other half of the city. Within the US, there are 6 different time zones. We are located in Central, which you should be somewhat familiar with. So I have 2 things in closing that I'd like you to do to help you kind of practice. I would like you to create a map of your route from home to school. And I want you to kind of include both things that would be pertinent to relative location and things that would be pertinent to more absolute location. Okay, I want you to show where PHS is. I want you to show where your home is. Maybe 3 landmarks by which you associate where you're at between these 2 places. Any stoplights, any labeled roads that might give us more relative or even absolute locations. If you want to give the exact address of Pasadena High School, that'd be great. You do not have to give the absolute location of your home. I have no interest. Okay, and then I want you to also provide written directions that can guide readers through the map provided so that they would be able to, say, find PHS from your home or find your home from PHS if they needed to look for it. All right, you don't have to put too much information if you're afraid of that information getting out, but it just kind of lets you get used to and recognize how we use absolute and relative location in our everyday lives. Okay, if you want to do maybe not your home, you could do something else. Maybe is there a place that you go after school to go to a certain sports practice or a certain store or a restaurant that you like to go to after school that you go to very often. Something that allows you to give directions from where we're at here at the school to somewhere else that you can identify. And also what I want you to bring in is a ticket in that says 3 things that you learned about geography tonight. 3 things from this presentation, or if you're catching up to another presentation, that's fine too. But I want you to write 3 things that you learned today that you didn't know before you went in here. Or maybe it's something that you forgot. And that is all I have for you for this presentation, and we will talk more about it tomorrow.